Recording in progress.
All right, all the students join the class. Let's start. This is the schedule for the calculus in this summer. We talk about the limit, and we also talk about the definition of continuity, intermediate value theorem. And then we start to do the derivative rules. We learn about the chain rule, product rule, quotient rule, okay? And last week, we talked about the implicit method. Today, we will use the implicit method to do the inverse trigonometries derivative. Topic of today is going to be hard for sure, okay? Everybody, please pay attention. We are going to derive the rules for the inverse trigonometries. Before we learn the derivative, we will quickly review the trigonometry inverse functions. Look at number 1. Tangent inverse 1 equals to how much? If you cannot write down this in one step, you say this is equals to angle alpha. That means tangent alpha equals to 1. Who gave you a value of 1? Pi over 4. So pi over 4 is the answer. You might argue with this. You may say 5 pi over 4. Tangent value is also positive 1. That's right. All students take class, okay? If you haven't learned pre-calc with me, you want to review the pre-calc unit circle, okay? All students take class. Quadrant 1, tangent is positive. Quadrant 3, tangent is also positive. What's the reason you only choose pi over 4? It is all because the vertical rule of a function. Your tangent graph looks like this, okay? Your tangent graph is a periodical function, looks like this. If you want to have the inverse function, your inverse function has to pass the vertical line test. So when you choose this, you cannot choose all the negative infinity to positive infinity. So you have to choose from negative pi over 2 to positive pi over 2. So that means this guy, tangent inverse range is restricted from negative pi over 2 to pi over 2. So you have to pay attention for the range of the inverse function. Here I give you a summary. Sine inverse, it is bounded between negative pi over 2 to positive pi over 2. Cosine inverse is bounded between 0 and pi. Tangent inverse is bounded between pi over 2, negative pi over 2. It is not going to be able to reach to this value because tangent inverse infinity go to pi over 2. So this won't be equal sign. Cotangent inverse is bounded between 0 and pi. You want to pay attention to those things. If you see, teacher, I totally forgot this, you can open a graph and you can see what does those guy looks like. So you can type in sine inverse here. This guy is bounded between negative pi over 2 to pi over 2, okay? Yeah. So I'm going to keep writing. How about secant? Secant inverse, you have to be very careful. Secant inverse, pi over 2 is the asymptote. Y equals to pi over 2 is the horizontal asymptote. So secant is it could be bigger than pi over 2. It is less than pi. Oh, secant inverse is bigger than 0, but less than pi over 2. It is bounded between these two, okay? Okay. On the two end, it can reach. How about cosecant? Cosecant inverse. Cosecant inverse it is bigger than 0. And then if you choose the negative part, it's going to be between negative pi over 2 to 0. Or it is bigger than 0, but less than or equal than pi over 2. For this one, y equals 0 is a horizontal asymptote for cosecant inverse. Okay. Well, you need to master this, and then let's take a look at those values. I'm going to start to call students, okay? Claire, how much is this one?
Okay, can I write like alpha on the other side just to use as a variable?
Uh-huh.
So that'd be cosecant alpha equals to 1/2, and that would mean alpha would equal to pi over 3.
Pi over 3. Okay. One more?
And pi over 3 and 5 pi over 3.
No.
No?
No, that's the only one.
Okay.
When you choose the cosine inverse, you can only have one value. Look at here. That's what we learned just now, right? You are bounded between 0 and pi. 5 pi over 3 is the wrong answer. You cannot choose that. This guy is the only guy. Okay?
Fine.
One more. Next.
Oh, okay. Okay, so that would mean if it's arc of cosecant, that'd be, wait, sorry, hold up. If cosecant -1 r of alpha equals 2 over 3, and then cosecant.
And this is cosecant. You change it to sine, which is reciprocal for both, okay?
Which is √3 over 2, and that would be also pi over 3.
Pi over 3. Okay, thank you. Angela, let's do number 4.
Okay, you make it equal to alpha, so then sine alpha equals to -√3 over 2, and then alpha would equal to negative pi over 3.
Can I say 5 pi over 3?
No,
Because of the range, right?
yeah, it's restricted.
Okay. One more.
Okay, so that equals to alpha, so then cosine alpha equals to √3 over 2, and √3 over 2, that's pi over 6.
Okay. One more.
Okay, that's equal to alpha, so then and alpha equals to -√3 over 3. I think that is negative pi over 6.
Okay, that's right. Don't change this to 5 pi over 6, okay? That's the wrong answer. Because tangent inverse is bounded between this, okay? So that's the only answer. If this is positive, that's positive. If this is negative, this is negative because this guy is between negative pi over 2 to pi over 2. Okay, all right. Cindy, let's see how much is this guy.
Okay, so inverse secant -1 should be pi, I think. So that's equal to alpha.
Yeah, we do secant alpha equals -1. That is saying cosine alpha is -1, right?
Yeah,
So alpha equals?
pi.
Very good. That's the correct answer. Next one.
Okay, for the next one, okay, so inverse cosine 0 is equal to alpha, and so that would be equal to pi over 2.
That's right. Very good. Very good. Next.
And then inverse cotangent 1 is equal to alpha. And okay, so tangent, that should be pi over 4.
That's right.
Mm-hmm.
Very good. If I change the question, this equals
3 pi over 4.
3 pi over 4. Very good.
Yeah.
If I change it to this,
I think that should still be 3 pi over 4.
nope.
No? Okay. Oh yeah, because there's like, oh yeah, there's different limits. Is there?
This should equals to negative pi over 4. Okay.
Mm-hmm.
All right. Thank you. Next. Tangent of cosine inverse 3 over 5. Okay. Joy, let's do this together.
Okay.
Yeah. We might not be able to do this in one step, but we can let alpha equals to cosine inverse 3 over 5. Okay. We can write down the alpha equals to that. That means cosine alpha equals to who? That means cosine alpha equals to this, correct?
Yeah.
Cosine alpha equals to 3 over 5. Cosine inverse is between 0 and pi. So cosine alpha equals 3 over 5. This angle has to be in quadrant 1, correct?
Yes.
If this guy is in quadrant 1, we can draw a terminal. Let's draw a terminal going like this. And then cosine is adjacent over hypotenuse. Adjacent is 3, hypotenuse is 5. This is a right angle. How much is this side?
Is it 4?
That's right. This is a 4. If this is 4, we are going to calculate a tangent. Tangent alpha, right?
Yes.
Tangent alpha equals to opposite over adjacent. So tangent alpha should equals
4 over 5.
a opposite over adjacent, 4 over 3.
Oh, 4 over 3. Yeah, sorry.
Tangent is opposite over adjacent, 4 over 3. The answer is 4 over 3. Okay?
Okay.
Let's do number 11. Same thing. When we want to calculate this value, we want to figure out the arc sine is how much. Well, we can get this guy equals to pi over 6 easily, yeah? Arc
Yes.
sine 1/2 30 degree pi over 6. Cosine pi over 6 is square root 3 over 2. We can also do the same way as what we do here. We can use 2 ways to verify our answer. Okay?
Okay.
Here is 1, here is 2. So how much is this piece?
Square root 3.
Okay, square root 3. So this angle is alpha. So cosine alpha equals,
Square root 3 over 2.
that's right, square root 3 over 2. This is the same answer as what we do cosine pi over 6. You can do from this way, you can do from this way, both way work. Next one, number 12, cosine of arc sine x. This is alpha. We make alpha equals to arc sine x. Alpha is the angle. So x equals to sine alpha. That means we can see here sine of this angle. The opposite is x, okay? And the hypotenuse is 1. Sine alpha equals x divided by 1. Now you want to get cosine alpha. So cosine alpha equals to adjacent. How much is this piece? If this is 90 degrees, this is 1, this is x, how much is here? Joy, how much is here? Pythagorean theorem.
Right. So would it be like x squared plus 1?
1 squared equals to x squared plus this guy. So this guy is going to be square root 1 minus x squared, correct?
Okay.
90 degree. This is x squared. This is square root 1 minus x squared. This guy squared plus this guy squared equals to 1. So this piece is this. Now cosine alpha is going to equals to 1 square root. So this is going to be adjacent over hypotenuse. Hypotenuse is 1. Adjacent is this. That's it. Make sense?
Yes.
Okay. Well, we can also use the trigonometry identities to do this question. In pre-calculus, we know 3 important trigonometry identities. Sine square alpha plus cosine square alpha equals to 1. Tangent square alpha plus 1. That's this guy. Cotangent square alpha plus 1 equals to cosecant square alpha. Okay. So based on this, we can also do the same way to figure out the value, right? Now, we can use the trigonometry identities. You know the sine value. So your cosine value is going to be using the square root and then 1 minus x squared. So you get your value. Use trig identity or use this graph, both can get the same answer. All right, that's for the quickly review for trigonometry inverse. If you really have trouble for getting those values or knowing those identities or knowing those range and unit circle values, you have to go back to revisit your pre-cal, okay? Now it's the time to do the trigonometry inverse function derivative, which is hard, okay? Now let's see the first one. y equals to this, equals to sine inverse x. Writing down arc or writing down sine inverse, these two means exactly the same things. If you have this, you can say sine y equals to x. Sine y equals to x. Now, I leave the trig identities over here. Use the implicit method. This guy derivative is cosine y. Y is also a function of x, y prime. X derivative is 1. Go ahead, based on this information, calculate the sine inverse function derivative. And then if you finish, send me a message saying you finish, okay? Let's see who can get it correctly. Anybody finished? Lawrence, let's do it together, okay?
Okay.
We want to apply the implicit rule we learned the last time, okay?
Okay.
Yeah, sine y derivative is who?
That's cosine.
That's cosine,
Cosine y. Yeah.
cosine y.
And we gotta
And
do
y
times
is,
derivative. Y
so
derivative.
y prime
Yeah.
equals
And that's just 1.
to 1.
Mhm.
So y prime equals to 1 over cosine y.
Mhm.
Okay.
Okay.
Now you have sine square y plus cosine square y equals to 1. So cosine, this is x, you put here as x. So we can
Okay.
go ahead and solve the cosine y. Cosine y should equals to square root
Square
of
root
1 minus
1 minus
x.
x squared.
So
Oh,
this equals to
1 over square root of negative 1 minus x squared. Oh, I see. Okay.
okay. That's what's going on. You have to know how this formula come from. You have to remember this formula also. So sine inverse function derivative is 1 divided by square root 1 minus that guy square. Okay, that's the formula. The next one. Olivia. Let's do cosine inverse derivative, okay?
Okay.
We write down y equals to arc cosine x. So x equals to cosine y. We can do the derivative for both sides. So 1 equals
Negative sine y.
very good. Cosine derivative is negative sine. So this is negative sine y times,
Y prime.
okay? So y prime equals to negative 1 over sine y. And sine y equals to this, based on the trigonometry identity, right?
Yeah.
So this is negative 1 over square root 1 minus x squared. You might wonder, during the test, will the teacher give us those formula? The answer is no. You have to remember those formulas, even though it looks so ugly, okay? Right now we are learning derivative. Later on, sooner or later, we will learn the integral. By the time we learn the integral, the question will become like this. If you have integral sign, 1 over square root 1 minus x squared dx, this guy equals how much? This guy equals to arc sine x plus a constant c value. So if you don't remember this, by the time you learn the integral, there's no way we can get the answer. All those formula, number 1, know how it comes from. Number 2, remember this. Number 3, being able to manipulate with those formula to solve the real question. Number 4, get ready for those integral questions. Okay, 4 different levels. Next one. Y equals to arc tangent x. Zhao Yuchen. Let's do this one. Y equals to this. How do we rewrite this?
Tangent y equals x.
Very good. Tangent y equals to x. Can we do the derivative for both sides? Who is this guy derivative? Remember, we learned about sine derivative is cosine. Cosine derivative is negative sine. Tangent derivative is secant square, right?
Oh yeah, secant.
So this guy derivative is
Secant square
y
prime
times y
times
prime
equals 1.
So y prime equals
1 divided by secant square y.
now we are going to use the trigonometry identities. Secant square y equals tangent square y plus 1, right?
Yeah.
This is the trigonometry identities. So who is this? This is x squared, right?
X squared at 1.
So that gives me x squared plus 1 and then divided by 1, right?
Yeah.
Okay. So you need to know the formula. Tangent inverse derivative equals to this. By the time we do the integral, when you see this equals to tangent inverse x plus a constant c. Okay, let's keep in mind for that. Next, Aiden. Let's do this.
Okay, sure.
For this, I rewrite to like that. What should I do next?
Take the derivative of both sides, so it's negative cosecant squared y times y prime is equal to 1.
So this is negative cosecant squared y times y prime equals to 1.
Yeah.
And then y prime equals
Negative 1 over cosecant squared y.
negative 1 over cosecant squared y. Cosecant squared y equals to who?
I believe it's cotangent squared y plus 1.
Equals
Oh, wait. Oh, sorry. Then after that, you can change it to x squared plus 1. So it becomes negative 1 over x squared plus 1.
okay. We need to know this formula. We need to remember this formula, okay? When later we have this. That is saying arc cotangent x. Well, that's the full formulas. Not too hard yet. This is not really hard. Let's do the next one. It's called y equals to arc secant x. Y equals to arc secant x. Okay. Angela. How do we write down the next step? This guy derivative should equals.
It's secant y times tangent y.
So secant y derivative is secant times tangent times
Y prime
equals.
equals 1.
Okay. So y prime equals to
Equals 1 over secant y times tangent y.
1 over secant y times tangent y. Okay.
Okay.
Now, secant y is given. This is x. It's time to calculate the tangent y. How do we calculate the tangent y? You do x squared equals secant squared y. Secant squared y equals to tangent squared y plus 1, correct? Yes, Angela?
Yeah.
So tangent squared y is going to equals to x squared plus minus 1. So tangent y, you are going to choose this one. You're going to choose this one. Okay. So that when we write down the y prime of this is arc secant x derivative equals to 1 over secant y times tangent y. This guy is x. This guy is square root of x squared minus 1. When you remember this formula, this is a very tricky part. You need to put a x absolute value here. The reason you want to keep this guy to be x absolute value, it is because it's because of this. This is your secant inverse graph, okay? You were given an original function as y equals to arc secant x. The red line is your original function. When you want to get the derivative, look at this. When your x is positive on the right part, on quadrant 1, the green line is exactly the derivative of the red line. Look at this. For this point, you have an infinite, positive infinity slope. That's why your derivative, the green line, go all the way to the positive infinity. When your x go to positive infinity, it's like a horizontal line. So your red lines is approaching to a horizontal line, okay? That's what it looks like on the left side. If you don't want to put the absolute value, if you say, I don't want to leave the absolute value there, then your derivative will look like this. For your right part, the red line derivative agree with your green lines in the quadrant 1. But for the left, the value is matching, but the sign is opposite. For the red line on the left, all those values, it is increasing. You should have a positive slope. The negative slope is not working, it's failing. That's why you need to leave an absolute value here so that the value and the sign match to each other. That's why when you have arcsecant derivative, you have to remember you put an absolute value for here, okay? Listen, the guy here is hard. I don't require everyone to understand this part. If you can understand it, let's do it. If you feel this part is too hard, it is okay. You just need to remember you leave an absolute value over here, okay? Is there any question so far? No question? From the arcsecant x, you already see that both x bigger than 0 or x less than 0, it is a positive slope. It is a positive slope. So your derivative has to be positive. When x is bigger than 0, then x is negative, okay? So you need to make sure this guy to guarantee this guy is positive always, no matter what, okay? So you have to leave an absolute value for here. If you don't have the absolute value, this guy is always positive, but this guy, when x is negative, this becomes negative, then this derivative value will be wrong. You need to leave an absolute value over there. Now we are going to talk about the next one. Aiden, let's see y equals to arc cosecant x, okay? Go ahead, tell me what I should do. Aiden?
Oh, sorry, I was muted. Okay, hi. Okay, you once again, I think, take the derivative of both sides.
So this is negative what?
For this one, it's negative, I think, was it like cotangent y times cosecant y?
Yes, that's right. Negative cotangent y times cosecant y equals
1.
equals to 1. Not really times y prime
Oh, oops, sorry. Times y
equals to
prime.
1, okay?
Right,
So
okay.
y prime equals to
Negative 1 over cotangent y times cosecant y.
okay. So now here, we know this guy is x, so this guy is x. And then cotangent y, we are going to do the square root. X squared minus 1, correct?
Right.
And then again, we can analyze arc cosecant x, okay? So we can do cosecant inverse x, okay. And this one on both sides, it is going down. Look at the graph. The red line is going down on left and on the right. So if you put this guy, both positive slope value, it's going to be wrong. There is a negative on the top. That's the formula to satisfy the y prime of cosecant inverse x. This is a formula.
Okay.
Okay. It's complicated, right? It's really complicated.
Yeah.
For both Dulles Academy and Clement High School, your AP class for calculus, no matter what it is, AB or it is BC, you need to know those kind of things. If they give you this guy, you need to write down who is the answer. You need to know that is cosecant inverse x plus a constant value, because that guy derivative is this guy. Constant value derivative 0, okay? Look, on the right, your derivative is that. And this guy derivative is exactly this. Integral is an inverse operation for derivative, okay? Keep this in mind. By the time we learn this part, it's going to be really hard. Everything we do right now are the foundations for running the integral correctly. All right. Now we are going to do the real practice. Let's see the question. The first one. If I tell you fx equals to this, and then I want you to do the derivative, the difference between this and the original one, the original formula sine, always write down arc sine, okay? Arc sine x derivative equals to 1 over square root 1 minus x squared, okay? When we have here, this is an easy question. Why? Because you just have a 2 outside. So as a constant coefficient, you leave it outside, that's it. And then you are going to apply the formula. The formula here is arc sine x. Here is x minus 1. So you are going to mix this whole thing as a package to plug in. 1 divided by square root. X squared is replaced by x minus 1 squared. Okay? So that is the answer. This question is pretty easy. Next, number 14. Number 14, you have 3 times arc cosine x over 2. So we just get the formulas over here. This is a formula. Cosine inverse x prime is -1 divided by this. What will happen if this guy is not x, if it's a u? You have to keep in mind of the chain rule. If this is a u, and u is a function of x, you leave this as u, and you have a negative u prime. That's it. So we come back to here. If you have arc cosine u, that guy derivative is using the chain rule. Previously is x, this is 1, because x derivative is 1. That's the old one. Right now, the guy here is not just a simple x, it's a function of x. So you call it u, and you do the chain rule, u prime, and then u square. So negative u prime, negative times this guy derivative is 1/2. 3, keep it outside, divided by square root 1 minus that guy square, which is x squared over 4. That's the answer for number 14. Now I pause a little bit. Is there any question? Is there any questions? No question? Okay, look at the question 15. You can go ahead and do question 15. You want to use the quotient rule, okay? Question 15, you want to use the quotient rule. And you also need to keep in mind of the chain rule. You do the top guy derivative times the bottom one minus the top one times the bottom one derivative divided by x squared. Okay, go ahead and do it by yourself, and then we can check the answers. If you finish question 15, send me a message, okay? Send a private message to me. I have 2 accounts login. I'm going to send out a message so that you just answer or reply my message. Who finished? Number 15. Nobody finished number 15? We use a quotient rule. This guy derivative is going to use this one, but the guy here is not x, it is 3x, so we have to use a chain rule. That guy derivative is 3x derivative, which is 3, divided by square root 1 minus 3x printed square, which is 9x squared. That's the derivative for this one, times the bottom, copy down, minus this guy, copy down, times this guy derivative, which is 1, divided by this guy square. That is the derivative, okay? If you want to take College Board AP test, either AB or BC, this is the easiest question for that test. You have to at least reach to this level, okay? Let's do number 16. Angela. Let's do question 16.
Okay. Do you use the product rule for this?
Yes, you use product rule first.
Okay, so you do 2x times arctan x plus x squared times
You know, by the time for in the test, if you forget about the formula, since we learned the formula, we can get it quickly. Yes, this guy.
yeah.
Rewrite tangent y equals to what? X. Tangent y derivative is who?
Secant square y
Times
times y prime
equals
1
y prime equals
1 over secant square y
secant square y is who?
is 1 plus x squared.
That's it. That's the reason I teach y'all how the formula comes from, okay? I can tell you your school won't tell you how you get this formula. They just say, remember this. I teach you this because I know that a lot of people cannot remember it. In case you forget, you still can get it, okay? Does this make sense now?
Yeah.
Okay. Cindy. Let's do number 17.
Okay, so okay. Okay, so what is it? The derivative is going to be a half times, wait, a half times,
We can write down this in several steps, okay? We can see, we want to do this guy derivative on the top, right?
yeah,
And then on the bottom is going to be who?
on the bottom it's going to be the derivative of,
So you do 1 plus who?
1 plus root x squared.
Yes. Correct?
Yeah,
So x, square root x derivative is who?
a half times x to the power of negative a half.
Divided by?
1 plus x.
That's it.
Oh, okay.
Make sense?
Mm-hmm.
Okay. Olivia. Let's do 18.
Okay. So 1 times arc sine x and then plus x times 1 over root 1 minus x squared.
Next.
And plus 1/2 and then times 1 plus x squared to the negative 1/2. Negative 2.
You did pretty good. This guy derivative is 1 times this guy copy down, plus this guy copy down times this guy derivative. This guy derivative is 1 over square root of this. And then we are going to do this guy. This guy is using the power rule. This is power of 1/2 times this guy to the power of 1/2 minus 1, which is negative 1/2. Because the chain rule, we had to do this guy derivative. This guy derivative is times negative 2x. Does this make sense now, Olivia?
Yes.
Okay. Any volunteer for the number 19? No volunteer? Lawrence?
So beginning, this is arctangent. We can copy down arctangent 2x because this is, I think, the product rule at the beginning.
X derivative is 1, so we copy down arctangent 2x plus.
Plus, is it like x? It's like x over x squared. Was it actually? No, it's not x squared anymore. Be 4x squared.
It's 1 plus, right?
A 1 plus, yeah, 4x squared, I think. The entire expression is squared. Yeah.
Do we have 2 times 2 on the top? Look, product rule. This guy derivative copy down this guy. And then this guy copy down this guy derivative. This guy derivative, you can leave 1 plus that guy square.
Right.
And then times this guy derivative. 2x derivative is 2. So you have here. Make sense?
Makes sense. Yeah. Okay.
Yeah. Do you still remember what's the derivative for the ln x? Who is this guy?
It's not like 1 over x.
That's right. So this guy derivative is?
Oh wait, so we pulled out negative 1 over 4, but we can just copy everything down. 1 over 1 plus 4x squared, I think.
We have to use the chain rule. What should we put on the top?
And we put 8x on top.
Very good. Very good. That guy derivative is 8x. Okay? That's good. And then we can do the simplification. This becomes 2x. Okay? And then look at here.
Okay.
This is 2x. This is 2x. Do they cancel?
Oh yeah, they do cancel because
they do cancel. Exactly. So the result is this.
It's just, oh, I see. Okay.
Yeah.
Okay.
Okay.
All right.
Okay. Question 20. Any students? No students. Aiden. How do we get the derivative for this guy?
Okay, the derivative of y is like, I think it's 4 over, was it the absolute value of x? No, the absolute value of 4x times square root of, I think, 16x squared minus 1.
Perfect. Very good. The original formula is saying you do that guy square, that guy x value, then square root x squared minus 1. Here is 4. So you put 4x here, and then you do 4x squared, which is 16x squared. And the 4x derivative is 4, so you have this, okay? Now they ask you, find the equation of the tangent line at the given x value. So let's make x equal this and figure out how much, okay?
Okay.
Let's go ahead.
So when we plug that in, we get 4 over square root of 2 over 4 times 4. So that's just square root of 2 times.
So 4 over square root 2 times.
That's 16 times 2 over 16. So it just becomes 2.
So this is
1.
2 over 16 and then minus 1. So this equals to
1.
1, because this is just 2 minus 1.
Yeah.
And then this equals?
It's 4 over square root of 2, which is equal to 2 square root 2.
So that is 2 times square root 2. And then we are going to plug in this guy into this. Let's see, when x equals that, y is how much?
Okay, so that's arcsecant of square root of 2. I think that was like pi over 4.
Okay, pi over 4. So we pass the point of square root 2 over 4, comma pi over 4. The slope is this. So we do the point slope format. Y minus this, y minus y0 equals to the k times x minus x0. Correct?
Correct.
Okay, that's the final solution. Okay, very good. Now we are going to do next one. We want to find out this one. Find the line tangent to this function when x is negative square root 3 over 2. Angela, let's do this question. F prime x equals to how much?
Equals to arc cosine x.
You want to do this guy derivative, right?
Oh wait, yeah.
Who is arc cosine derivative?
It's negative 1 over root 1 minus x squared.
So it is negative 1 over square root 1 minus x squared. And you have a negative 2. We just put the negative 2 in front, okay? Now, when you have a coefficient, just leave it outside and times the whole package, okay? So you have a negative 1 on the top, and you have 1 minus x squared, correct?
Yeah.
Now, this is the slope. Let's plug in x equals to negative square root 3 over 2. So 1 minus negative square root 3 over 2 square. How much?
So it's 1 minus 3 over 4, so it's 1/4.
That's a slope. Let's find out the y value.
So then it's -2 times -1 over 1/4.
Arc cosine. Who is this guy?
It's 5 pi over 6.
Pi over 6. So this is -2 times pi over 6. This is negative pi over 3, correct?
Yeah.
Okay. Now use the point slope format. Go ahead.
So y plus pi over 3 equals to 1/4 of x minus x plus root 3 over 2.
Okay. Does this make sense?
Yeah.
So the physical meaning of this is this, okay? You have your y is equals to arc cosine x, and in front you have a -2. You have a -2, okay? This is your original function. And you have a point. You have a point at negative square root 3 over 2. Y value is negative pi over 3. And then let's double check why the point, why this point is not on here. Hold on.
Wait, when you said pi over 6, shouldn't it be pi over 6 because it's negative?
Yes. This guy here, we got something wrong over here, okay? Because this is negative, arc cosine has to be between 0 and pi. And that's the reason we want to fix here. This is -2 times 2, 5 pi over 6, right?
Yeah.
5 pi over 6. So this becomes to -5 pi over 3. That makes sense? And then we are going to change this to be y minus -5 pi over 3, which is y plus 5 pi over 3. Does this make sense now?
Yeah.
Okay. Now this point, yes, this point is on the line. And then if we write down that, we say y plus 5 pi over 3 equals 1/4 times x plus square root 3 over 2. What's going on? It is not showing correct. Let's double check our work, okay? F prime of this guy is -2, yes, times -1, and then square root of 1 minus x squared. The formula here is showing correct. Okay, so far no problem. And then when x equals to -3 over 2, 1 minus this guy, this is 3/4. So this is 1/4. Oh, 1/4 is here. That means what? This is, hold on, we got something wrong over here, Angela. Look, square root of 1/4 is 1/2, right?
Yeah.
So if we move this guy over there, this is basically saying when we plug in x equals to that, this equals to -2 times -1 is +2. 2 over square root of 1/4, which is 4, right? Yes. 2 divided by 1/2 is 4. Makes sense?
Yeah.
So the slope is not 1/4, the slope is +4, right?
Yeah.
Makes sense now? So the slope here is not 1/4, slope is 4. Now this is correct. Look at this. By giving a point, giving a function, we are able to find the tangent line for this graph based on getting the slope correctly. Calculating the slope by applying the arc cosine formula correctly. But when we plug in the value, we have to be very careful. Here is 1/4. Square root of 1/4 is 1/2. 2 divided by 1/2 is +4. It is not 1/4. That is wrong. So the slope is 4. The slope is 4, and we get the x value as this. When we plug in the x value, we find out that our y value is here. If we give this as a wrong answer by saying -π/6, that's going to be wrong. This is a 5π/6, okay? 5π/6 times -2 is -5π/3. So the correct point is x as -√3/2. Y is -5π/3. Y minus that, y minus this equals to x minus this. Because negative, that's why we have positive here. And if we show the point here, this exactly shows our answer is correct, okay? Yeah, to do question here correct is not easy. You have to have really strong foundation for the inverse function, inverse trigonometry, unit circle, plus with inverse trigonometry derivative, okay? Yeah. Now we can practice. We have more worksheets for here. Let's take a look at this. For this question, the first one, any volunteer? Claire, let's do this one.
Okay. So can I do the bottom first and then move on to the top because I'm not quite sure for
Okay, go ahead.
Okay, so the denominator would be square root of 1 plus 25x to the power of 6.
So the denominator is the square root of what?
1 minus 25x to the power of 6.
Yes.
Okay. I'm not sure the top.
The top one is going to do this guy derivative, okay?
Oh, okay. So that would be 15x squared.
That's it. -15x squared, okay? That's it. Thank you. Number 2, Joy, let's try number 2.
Okay, so for the arc sine of for arc of sine x, it would be 1, is it positive 1 over and then square root of 1.
So, okay, hold on, okay. We are going to use the formulas when we have, let's see. Formulas is this. This is the list of the formulas. Previously, we do the simple case. If this is x, x derivative is 1. This is x squared. But now, there might not be a simple x there. So we want to do the chain rule. So look at this. For this one, we want to manipulate with this formula. Okay? So u is going to be this. So the top one is going to be that guy derivative. If you cannot do this in one step, it's okay. We write down extra step. Yeah, we write down that guy prime divided by
1 minus negative 2x squared.
We want to put the parentheses, okay?
Yeah.
So this equals?
So the top would be negative 4x. And then the bottom would be 1 minus and then negative 4 x to the 4.
Yeah, that's it. Very good. Okay. Yeah, you got it. Yeah, let's do one more, Joy. Let's do one more. Number 3.
Okay.
Look, formula is here, okay?
Yeah. So for the top, you would do 8x cubed.
Very good.
And then the bottom would be 1 plus 4x to the 8.
That's it. Very good. You made it. Nice. Thank you. Zhao Yuchen. Yeah. Formula on the left, okay? Let's apply this formula.
It's equal to divided by x.
Yeah, we'll do negative, okay?
I mean, okay.
Negative, and then we do that guy derivative, okay? So we can write down this in extra step. Divided by absolute value.
Yeah.
Full x squared absolute value, okay? Times
16x.
So we do full x squared, right? And then minus 1. Does this make sense to you?
Yeah.
Tell me the next step. This guy derivative is who? Power rule.
2.
Negative 4 times 2x, right? Which is negative 8x, correct? And then the bottom one, 4x squared absolute value is just as 4x squared, okay? And then 4x squared will be 16x to the
Right.
power 4.
4 and minus 4.
That's it.
Oh.
Make sense now?
Mm-hmm.
Okay. Lawrence, let's
Right here.
see number 5. This is a little bit tricky, okay?
Okay.
Now let's see the outlier is who.
Okay. So you do. Okay. Do we do the in layer first before the power 3?
We do from the out layer and then the inner layer, okay?
Oh, okay.
We do power rule first.
Oh, power fourth. Okay, I got it.
Okay.
So you do 3 times, and then all that copy down, but it's to the power of 2. Oh yeah. Yeah. Okay, and then we do the inner layer, which is 5x squared, I think, and then that's derivative.
Yes, this guy derivative.
Yeah, over, and then square root of 1 minus, and that'll be 25x to the power of 4.
Yeah,
Yeah.
I'm going to write, So I'm going to write down in extra step. This is 3 times.
Okay.
Copy down this. And then
Right.
times
And
x
top
squared
would be
derivative is
10x.
10x, very good.
And square
Over
root of 1 minus 25x to the power of 4.
that's it.
Okay.
That's it. Not too bad, right?
Yeah, not too bad.
Okay, hold on. You do one more. Number 4, number 5 and number 6 look so similar, but they are totally different.
Yeah.
This one, your inner one is the inverse function. Your outer layer is the cube. This one, your outer layer is the inverse. Your inner one is 3, okay? This is really tricky. This is a good question. You put them side by side. That's a good way. Let's see, how do I do this one?
Okay. To do that. So I think you would do the derivative of that whole entire thing above.
Yes. We
First.
want to do that whole guy, okay? This is going to be your u, all right?
Okay.
This is going to be your u.
Right.
So if we feel this part is really, really tricky, we can rewrite this, okay? We say u equals to this, right?
U equals 3, yeah.
Yes.
Yes, we can also do that.
We can write down that.
Yeah.
Y equals to sine inverse u. Okay? Now we want to get the dy over dx, okay? Dy over dx is dy over du times du over dx, correct?
Yes.
Who is dy over du?
Wouldn't that just be the u prime?
It's going to just be the one, if dy over du, u is your independent variable. So you just do 1 over square root of 1 minus u squared, okay?
1 minus u, okay.
Yeah.
Okay,
and then du over dx is going to be 3 times 3x to the power 5 plus 1 to the power 2, correct?
Okay.
But because this guy is not x, so we have to do this guy derivative one more time. We have to do that guy derivative one more time, which is
15
times 5 times x to the power 4.
Yeah.
Correct?
Correct.
Okay. Now let me squish this a little bit. Yeah, I think this is a very good question, right?
Yeah.
So we can do this. We copy down In the original one, we only have x, so we have to copy down all our x back, okay?
Okay.
So u is going to equals to that. So I'm going to rewrite this. So 1 minus square root 1 minus u squared is going to be 3x to the power 5 plus 1 to the power 6. Yes?
Power 6. Yeah.
That's the answer. And then 3 times 3 is 9, times 5 is 45.
45. Okay.
Yes. That is answer. Okay?
That's the answer.
Yeah, you do very good.
All right.
This is amazing. Very good. Thank you.
Thank you.
Okay. Olivia. Let's try number 8.
Okay.
Yeah, I leave the formula on the left. Okay.
Okay, so
Let's try if we can do this in one step. Okay.
okay.
So y prime is going to equals to the out layer is that guy. Okay. The out layer is that guy. So we are going to do the whole thing, the whole guys, the whole package derivative. Okay.
Okay.
Yeah. Divided by who?
Divided by the square root of 1 minus the whole square.
All of this to the power 3 to the power 2, which is to the power 6, right?
Yeah.
Okay. And then
Oh wait,
let's do it.
Isn't there
What?
a like
This one?
the numerator? Isn't it supposed to be negative?
Oh, yes. Very good. Good catching. Negative on there. Yes. Good. This is negative. And then equals?
Okay, so it's 3 times negative 2x cubed minus 3 squared, and then times negative 6x squared.
Very good. That's beautiful. Next, divided by? Okay. This guy. This is negative. To the power of even number, you can flip this to be positive. It's going to be the same answer, right?
Yeah.
Okay. That's it. That's the answer. Okay. Yeah, you can do this together, and you can also make this to be positive because this is even, right? That's even. Okay. Yeah. That's it. And that's the answer for question 8. I think this is very good practice. They put those similar questions on both sides, and you are going to drill your inverse trigonometry formula with the chain rule, power rule together. Okay. So that's for today's class. I'm going to upload the homework. Okay. Okay. I will upload the videos also. Yeah, I think most students already understand. Practice, make sure you can do all the homework by yourself. Okay. See you next week.